Okay, so now I will be looking at number 5, A, B, and C. Number 5, A, B, and C. So this is talking about some elevations of roads. So there's a company being managed, and they have these different elevations of roads. So now we're talking about all of these are positive. So these are all above sea level, but different levels above sea level we can see. So it says that the landowner wants to flatten these all out. Flatten them all out so they match the road. The road is at 830 feet. So look at all of these and how they compare to 830. Not quite 830, so it's lower than. Just almost right at 830, but a little above. Quite a bit above, below, and below. So again, it all compares to the road level. They want to level these out so they're even with the road at 830 feet. So this question, when it says compare, that means, is it more, less? How does it compare? That's what that verb means. So here, I want to say something about sample B compared to the road. So let's look at sample B. Remember, my road is 830. So how does this compare to 830? So I'd say sample B is higher than the road because it's higher than 830. Not by much, but it is higher. Then it asked me about sample, so there's B in our explanation. Asked me about sample C. So it says sample C is blank than the road. Well, let's look at sample C. Again, we're comparing to the road. My road is 830. How does 832 compare to 830? Of course, it's more. It's a bigger number, so that means it is also higher than the road. And finally, it asks us to look at sample E, 825.8. And so sample E is obviously, if 825.8, yes, it's got that decimal, but 825, if I compare the ones places, right? Clearly not as big. So I'm going to say sample E is not, I'm not going to say less than, I'm going to say it's lower because we're talking about elevation. It's up and down. Lower than the road. Some of you took this explanation even further. And you said, oh, in this case, it's 2/10 more. Nice work. And this one you said 2 ones more. That's also great. Or here you said 4.2 lower. Those are all good things to add in your explanations as well. But here, this is kind of what I was looking for when I say compare them to the road. Higher, higher, lower, okay? Let's keep going. So then it kind of resets your numbers. And it gives you some new samples. So we've moved on. And so these new samples are above or below the 830 mark. So for example, G, it's positive. So that means it's 3.1 feet above the road. Negative 0.5 feet negative, so it's below the road. So you can imagine what some of these other numbers mean. First, it just asks you to think, well, least to greatest. So we had some pretty good success here. A lot of you took your negatives first and said, oh, they're negatives. They're on the left, so they're not worth as much. Great. So you gotta think which one of these is furthest to the left. Well, H and L, those are between 0 and -1. Those aren't very big. But negative 4.5 is even further to the left. So that means it must be my smallest number. Then we just have to decide which one's further left, 0.5 or negative 0.9. So this one would be 5 tenths units to the left. But this one's 9 tenths units to the left, so it's even further. So then it's going to be 0 and 9 tenths, negative 0 and 9 tenths, negative 0 and 5 tenths. And finally, we get into our positive numbers. So let's think. Positive numbers, so maybe I'll put a box around those to make those a little more easy to recognize. Well, which one's the smallest? Let's look at the ones place. 3 in the ones, 2 in the ones, 1 in the ones. Obviously, 1 in the ones is smallest, followed by 2.2 and 3.1. So there we go, least to greatest. Now, we know this means 3.1 above or half below, 2.2 above, 1.3 above. It wants to know, it doesn't care about above or below for question C. All it asked about was which one's furthest away from the road. Remember, all of these show how they compare to the road. So that must mean 0 is right at the road. So we can be thinking here, if I'm thinking about the distance from 0, distance from the road, that means the same thing as distance from 0. So that means you're asking me which one's furthest from the elevation of the road. That's like saying, what's the one that's the furthest from 0? Okay, well, I know absolute value can help me find distance from 0. So let's find the absolute value of each of our numbers. So we have a total of 6 numbers, so let's do 6 absolute value symbols. Make a little room here. So let's get our numbers in here. We have 3.1, negative 0 and 5 tenths, 2 and 2 tenths, 1 and 3 tenths, negative 4 and 5 tenths, and negative 0 and 9 tenths. So remember, absolute value, always positive. It's always a distance. So here, 3.1, or 3 and 1 tenth, 5 tenths, 2 and 2 tenths, 1 and 3 tenths, 4 and 5 tenths, 0 and 9 tenths. So these all tell us how far they are away from 0, how far they are away from the road. Which one's furthest? Well, definitely not this one. That's 0 ones, 1 1, 0 1. So these, we can kind of we know those aren't the ones. So let's look at these now. 2 in the ones place, 3 in the ones place, 4. 4 are definitely the biggest. So let's see how we can write this. Indicate which one is, okay. So we think it's K, negative 4.5. So sample K is furthest from the road because, let's see, let's think about this. We could say something like, what kind of absolute value does it have? We're looking for the largest one because it has the largest absolute value of all the samples, And you might even be amazing enough to take this further and set up inequalities and compare things. So you might say, okay, well, this is my smallest one, 0 and 5 tenths. So that's obviously less than 0 and 9 tenths. That's obviously less than 1 and 3 tenths. That's obviously less than 2 and 2 tenths. And we could just keep going until we finish our list, and we would still see, oh, here's 4.5, the biggest absolute value, bigger than all the rest. Bigger than all the rest.